So we're going to start on our project and I'm going to define the project. So I'm going to define it, give you the constraints to the project, and then you're going to design it. Okay. So kind of the point of the project is to demonstrate your graphic skills that you've learned. So you can do that in AutoCAD or you can do that hand drawing, which is what we did in this class, right? But I know some folks have AutoCAD and they might want to use AutoCAD. That's fine. If you haven't had AutoCAD and you don't have it and you don't know that skill set, then don't use that. Just hand draw it. Okay. But the project's going to start today and then it'll be ending on the 21st. So actually, let's make it a week. So let's make it the 22nd. That would make more sense. Right before Thanksgiving break. So you'll submit it there. I'll give you the constraints. Well, actually, we should walk through the constraints, but then I have to talk about sketching and isometric sketching a little bit. Actually, let me do that first because you're going to get lost in the project once I share it with you. So I'm not going to do that yet. All right. So one of the parts of the project is you have to have a cover page. You could call it a page, or you could call it a cover drawing. And it should be an assembly. So typical assembly is going to be a number of parts coming together. Sometimes you see an assembly in section form. So I'm just going to show two parts coming together, right? This part and this part. So when we do detail drawings, like if we're going to do a drawing on a part, we want that part separated from everything else. And we just want to draw that part and dimension it, right? But in the beginning of a drawing pack, a lot of times you'll see an assembly. So maybe this is the assembly, you know, maybe there's a bolt that goes all the way through the assembly type of thing, right? And then maybe a nut on this side. So the assembly should show all the parts. And it also often shows the parts in what we call section form, which means it's like it's cut in half. So it's sliced, and then we hatch in each part. Right? So something like that, where this is clearly a different part than this, and then the bolt is a different part, and it's like it's all sliced in half. So you'll see assemblies like this. For your project, I'm not sure that's the best way to go about the assembly, but you can do it this way if you want. The goal of the assembly drawing is to identify every part, right? So this would be, you know, potentially part A, this would be potentially part B, and this would be part C, right? Identifying all the parts. So this is part of the assembly cover page. The other way it can be shown is in a isometric form, which I probably am not going to be able to do quickly, perfectly, but I'm going to give you a feel for it, right? So an isometric sketch is off at 30 degrees, typically. You can make them a little flatter and it'll show a little more of one side than the other. A little steeper, it'll show a little more of the top. But essentially you're setting up this isometric axis and you're sketching. And the goal is to keep everything parallel. So if I'm sketching on this side, I keep vertical things vertical and sidelines parallel, and you get a pretty, whoa, see, that was bad right there. You get a pretty good little isometric view of something, right? So you can do the assembly this way too. It's not that hard. You just take your time, and you know, the other part maybe is in here like this. It's on top, so I'll kind of draw it on top. Right? Keep everything parallel, and you know, things start to look okay. Not typically going to show hidden lines in this kind of drawing. So some of these lines will go away after you kind of get it sketched up, right? This line would go away. This would go away. and we start to get like a pictorial view of the objects, right? And then I could just put the bolt head in here. It's going to go down and through. So this would not be section form. This would be like pictorial sketching, right? Again, the whole goal is to identify part A, part B, and C, right? And sometimes it'll take like, you have to rotate it and kind of do another isometric sketch to see all the parts. If there was a part back here in the back, you could maybe just sketch that part in back there, and then this would become part D, right? So it doesn't have to show the whole part. It just has to identify each piece, because then the user will then flip the page, and then in the title block, it would say part A, and then you would have the full drawing of part A, right? Front, top, side view with all the dimensions. Then you flip the page again, and you'd see part B. Again, front, top, side of part B and all the dimensions. Does that make sense? That's called a drawing pack or an assembly drawing. That's what I want out of the project, is I want an assembly drawing. I want this kind of front page, right? And so the page, you're going to use B-size paper. B-size paper. You want to have a title block. You can put the title block on the side or down below, whatever's comfortable. Just make them all the same. Every page the same. Obviously a different title, and you might add, one of 6, because there could be like 6 pages, right? And then it would be 2 of 6 and 3 of 6. So that'll be kind of new in your title block, but the rest of the title block is going to be very similar. And then the assembly drawing would be here, showing the parts and pieces. And then often we have a table, right, that says, part A and then the name, part B and then the name. Sometimes there's quantity in there. Like if there's 4 of something, maybe there's, 4 bolts. You only call it out once and then you say quantity 4. So this drawing, it doesn't locate anything. It doesn't have any dimensions on it. It just gives the user like a map of the project, right? And they know, oh, if I want to know something about part D, then I thumb through the drawing pack and look for part D, and then I have everything I want about part D. Okay, so this is kind of new. We haven't done this yet, this little cover page thing. Again, you can do it in isometric form, or you can do it in what's called section form, right? Where you kind of put the assembly together and chop through it. Sometimes this is hard to see all the pieces with that single cut. All right, questions? That make some sense? Just think of it as a map to the drawings underneath, right? I should be able to look at that front and go, okay, I'm curious about this part. And then I thumb through and look for part B, and I have all the information I need about part B. All right. Yeah, you kind of want it to look like an assembly, but like in real life, maybe that's actually all the way together. So yeah, when I do these kind of assemblies, sometimes I'll put it like solid up against it, like maybe here in the back, because I'm not, maybe the gap doesn't make sense back there. And I can easily see the difference between these things. But like here, I'd want to know that there's 2 parts and potentially there's a space, or maybe there's not a space. Maybe they're meant to come together, but there's probably a clearance of some kind. And I would exaggerate that a little bit. So this is kind of flexible. You could have made it just one line, and maybe that makes sense, with this system, that probably would have worked just with one line. That'd have been fine. I tend to, like, especially when I sketch, I tend to like, okay, the point of this is I'm calling out different pieces. So if it's not clear, then you'll see these things even with a big gap, like exploded view, like it's pulled apart. And the thing's meant to come together, but each part is like separated away so you get a better feel for the part. So you can do it that way too. You'll see it a number of different ways. So same with this one. This maybe has just a solid line, And then the hatching kind of goes different directions for each part. So again, it's not meant to be the full description of the part, it's just meant to be a map. So I want that. That's kind of new. All right, so let's talk about the project. So it's going to start here. You have all this week and over the weekend, all the way up till Thanksgiving. I don't really want it to drag out over Thanksgiving. I'd rather you just have a nice holiday and not have something to think about. But let's look at the project, because you may have questions. And if you have questions after today, just don't hesitate to email me. You're going to design a human pod, is what I called it. Okay, so this design's completely up to you. It's meant for sheltering a person, okay, from the elements. So what it's going to be made out of, I hope this share works. It's important what it's made out of because you have to accommodate this material. So it's made out of this 1-inch foam, 1-inch thick foam, okay? And then we're going to skin one side with aluminum. That'll be the exterior. And then one side with 8-inch plywood. And you just glue it on. It's called a structural panel, right? You can buy these, but they're super spendy, very expensive. But you can make them a lot easier. You just take some either epoxy or a glue that won't eat the foam, like a contact cement. And you literally just glue on the aluminum on one side, by sheet aluminum. And then you glue on the plywood on the inside and you have a structural panel. It's called an insulated structural panel. I think it's called a structural insulated panel. They call them SIPs, right? SIP. So if you Google SIPs, you'll see all kinds that you can buy. We're going to make our own. That's the plan. So it's going to end up to be 1 inch plus 1/8 plus 1/8. So basically 1.25 inches, maybe a little more with glue. Okay. And then we're going to finish the edges. If you want finished edges, again, this is your design. You can kind of decide how you want these panels, but we would finish them with the aluminum. So it's kind of structural on the edges. And that could accommodate welding a hinge on if we wanted something to hinge, right? That could accommodate putting two panels together and then gluing on another piece of aluminum to make them completely solid if you want the corner solid. We can do a number of things with an aluminum side that we can't do with two wood sides. Like 1/8 wood is not much for a screw to go in to mount something. That doesn't work, right? You can through bolt it. That's complicated and more work than we need. So we're going to make one side aluminum and one side wood. All right, so here's the constraints. It's got to accommodate a 6'2" person. So there's two modes. There's sheltered mode, and then there's transportation mode or mobile mode. Okay, so in shelter mode, that person would lay down in there. So it doesn't have to be 6'2" tall. It just has to accommodate a 6'2" person inside. Want to have a padded floor? I'll let you figure that out. Constructed out of the material I just talked about. All hard walls. So this is not a tent. This is all structural panel all the way through. You have to push or pull it. So it's got to be mobile. I think it says down here, movable, but stable in shelter mode. When it's in mobile mode, it's got to accommodate 2 big weatherproof bins, and I'll let you spec those. You know, Home Depot has them. You can look online and look up a weatherproof bin. But when you move this thing around, we want those bins to be on board somehow. Okay. Snap together. We want it super simple to set up and break down. So light, like to be able to vent it in the summer, close that vent off in the winter. It's going to be warm. It's going to be an insulated structural panel. These panels are light. If you've never seen these panels or touched them, they're feather light, super light, and they'll break like easy until you put the aluminum on and the plywood on, and then they're pretty firm. they will not break easy. You could almost just support both ends and stand on it. So they're incredible. That's it. Those are the constraints. When you move it, it needs to be some movable system, whether you push it or pull it. So it's got to be able to move easily. Drag it around. Nope, the bins are just for personal items. So the bins are just for putting things in. The bins can, take them off, put them on board, whatever. They just need to go with it, be able to go with the system fairly easily. So an example of this, it could fold down, right? Fold down, fold up. When it folds down, the bins go on top somehow and are fairly secure there. When it folds up, obviously you just take the bins off, you fold it up, snap it into place, and you have a shelter. Nope, because they're weatherproof. They can just be outside. Yep. Good questions. Good. So it's not, I don't think it's too complicated. A lot of our designs might look exactly the same or similar, but there's a number of variations number of roads you can go down with the little shelter. So it needs to be stable when it's in like shelter mode. So if you put it on wheels, that would be one way to move it around, right? Put it on casters or whatever, then somehow it just can't be like on wheels when you get in, or, however you decide to make it stable for getting in. Questions? No? Piece of cake? The parts are not going to be like difficult to draw. There'll be some difficult areas. So, and you'll have to do obviously some scaling to get the parts on a piece of paper, but that's going to make other parts really small. So a strategy to deal with that is called detailing. So an example of detailing is just creating basically a zoom effect. If you're thinking AutoCAD, it's just a zoomed up effect of a certain part. So let me go back to the pencil paper. So an example would be like if I had, an object, let's say I have a thing that's like, 78 inches by 24 inches. But then down in this corner, there's like this little, piece of geometry. To get it on the paper, this geometry could be tiny, like really tiny. So just a simple way to do that is you can just call out a detail. So you just get the graphic on there somehow, like, it can even just be a dot, but what I would do is kind of blow it up a little so you at least see it here. And then, call detail A, and then down here you'd have detail A, and it would blow up that geometry, right? And then you don't have to show the rest of the part. We know it's here. If you want to locate it, then maybe you put this corner on, and then this becomes a dimension, right? But now I can actually pull some dimensions off and size this thing where I could not do it there. Does that make sense? So essentially you're just blowing it up. This would have its own scale. So this might be like 10:1, right? And this might be over here, like, I don't know, 1:6, right? So some reduction here, but then this scale is like flipped. It's actually blown up so I can see it. So you do have to reference a scale with that detail if you blow something up. And this will probably be a strategy you'll have to do because you're going to have some big parts with some small geometries, right? Try to use symmetry to your advantage, If one's over here and one's over there, then you just want to have to draw that once, right? And then this could get called out as detail A also, and then we can let the manufacturing folks figure out that that distance and that distance are the same. That's a pretty straightforward thing. So any geometry like that, you might have to make details on that page, or it could be another page. Like if it just doesn't fit on the page, then these details can float. They're not in projection. It's best if they're on the same page, because the user is going to be like, where the hell is detail A? Flipping through the drawing pack looking for it, right? So it's best if it's on the same page. But we'll see. If we actually get a fantastic design, I would like to make one. Yeah. So, correct. Be fun, wouldn't it? I think it'd be fun. All right. The good news is I recorded this. I don't have to go back through it. I feel obligated to, though, for some reason, but I'm not gonna. I can talk to you about it when I turn the recording off. So we're good. Let's go back. Stop share and then go share. Any questions on any of this? The constraints? I mean, they're pretty straightforward. You definitely have some design things to figure out, like how are we going to do this as simply as possible. I literally just want it, like the inspiration came from these rooftop tents. I don't know if you've seen rooftop tents on top of Jeeps. The craziest damn thing. I would never want it, but there are some cool ones that have some pretty nice engineering in them that literally just boom, but snap up, and it's done and then snap down. So that's kind of the inspiration. You can look at some of those for how it's done, and copy. That's all good. That's good design, is looking at doing research and looking at what's done. Then come up with your own way. But I don't want like fasteners. I don't want to have to put, nuts and bolts together to put it up. I want it to literally snap into place or somehow easily go into position and be fairly structural. It's only going to be so structural when you put it together that way, but I think it can be done pretty well. So. All right, I'm going to shut the recording off and then field more questions if we have them.